Okay, so a very good morning to all of you. So perhaps I hope your Diwali and Bhai Dooj has gone well. And for today, we'll be discussing about the rest of the uh, external data moves and code memory data move instruction set. So in the previous one, we have discussed up to this one. Okay, that is the indirect addressing mode. Now we will be discussing about the external data moves. As we know that microcontroller 8051 is capable of handling only 8-bit data. It can process, it can store only 8-bit data. But what happens when some 16-bit data is present? Now, 8051 needs to calculate or process the 16-bit data. It may be there. So, in case of this only 16-bit register that is present in the 8051 microcontroller, there is the data pointer, and this is denoted by DPTR. This DPTR is nothing but only the 16-bit register that is present in the 8051 microcontroller, and that is used for handling or processing or movement of 16-bit data. Okay, as we know that the data pointer register is having two 8-bit registers. It consists of two 8-bit registers, that is data pointer high and data pointer low. We have seen earlier in the internal RAM structure section. So for example, here is written movex a comma at the rate of dptr. That means we have discussed in the earlier classes also that at the rate, whenever this at the rate notation is there, then what is the function? This at the rate,
Address at the address of DPTR.
not address of dptr, the content of the dptr will be acting as the address. Okay, just like in the previous one we have discussed this rp. Just a minute. This rp, at the rate rp, that means whatever the content of the rp, that will act as an address. So here also this dptr is storing some 16-bit data, and this 16-bit data is acting as the address. So for example, we can see this we can see this move dptr comma hash 8000H. That means the dptr is loaded by this 8000H immediate data. So the content of dptr is now 8000H. Now movex a comma at the rate dptr, that means the content of the dptr, that is the 8000H, in that this content will act as an address. So in 8000H memory location, whatever data is there, this data will be moved to accumulator or a register. And now just see that move x is there. So what is the function of x? That is move external. X means external. Okay, whenever some external data, that means the data is coming from the external RAM, then this instruction will be executed. Clear? No other, I mean, this movex instruction cannot be used for the internal movement operation. Then we have to use mov only, move only. Clear? So move x, that means external RAM, from external RAM to internal, internal storage or a register, and from a register to external storage. Okay, that is RAM, not storage, that is memory. Okay. Similarly, in the second case, you can see this in the second case, movex at the rate dptr comma a, that means the content of a register that is moved into the memory location that is located by the data pointer register. Now in the example, move dptr comma hash 8000H, again the data pointer register is loaded by 8000H. Now the dptr is pointing towards the 8000H memory location. So the content of a register will be moved into the 8000H memory location. Clear? Now you may ask that sir, there is written 1 bytes. These two instructions are there. Please don't focus on this one, okay? Because this is the initialization message or instruction. Only focus on this one. Clear? Move dptr and movex a comma at the rate of dptr. So no 8-bit data is there, only mnemonics along with the registers. So single byte instruction. Similarly, this one also. Okay. Now coming to the third one, movex at the rate rp comma a. Now this this may be required that the external address is to be stored into the RP register. Now remember, this RP register is only R0 and R1 in the register banks. Okay. So here also, for example, the same example, again, you need not to focus on this instruction. Okay. I'm just pen through. So movex at the rate R0 comma A, that means the content of A register is moved into the memory location that is located by the R0 register. Similarly, in the last case also, there is a reverse of this. The content of the memory location that is located by the for example, in the R1 register, that is moved to the A register. That means the R1 register is having the value of 80H. Okay. So 80H will be acting as the address. Okay. Clear? So this address, whatever the content is into the address, that is moved to the A register. Okay. Just this one. Clear? Any questions you can ask? Okay, no questions. So we are going forward. The code memory read-only data moves. So as the heading implies that read-only data moves, that means these data movements are happening inside the ROM area. Okay. So in the ROM, we know that in the ROM, that is some program is written. Okay. That program is written means whenever you are writing some program, this by default stored, this is by default stored into the read-only memory, that is ROM. Now we know that 4 kilobytes of ROM is available on chip in case of 8051 microcontroller. Now if the memory exceeds the program length exceeds 4 kilobytes, suppose the program length is 5 kilobytes or 6 kilobytes, then this program totally cannot be written in the internal ROM. So we need to connect external ROM. Now this is not like this कि ये 4 kilobytes जो जगह है, जो space है, that is utilized in the internal ROM, and rest 2 kilobytes will be used in the external ROM. This is not the case. ये बात नहीं है. The thing is, whenever the program length is exceeded 4 kilobytes of space, then we need to connect external ROM to store the total program, to write the total program. Clear or not? Okay. So here also you can see this move C A comma at the rate of A plus dptr. After this A, here some comma is given, so it will not be there. Okay, this will not be there. Okay, so move C A comma at the rate A plus dptr. That means, just for the example, you can see this move dptr hash 1234H, move A comma hash 56H. That means A plus dptr, what is the function, what is the value of A plus dptr? That means 1234H plus 56H. Okay, so it will come like 128AH. Okay, 1 to 8AH. So 1 to 8AH in the memory location of 1 to 8AH, whatever the content is stored, that is moved to the A register. This is the concept. Understood or not? Please tell me, otherwise I cannot understand that whether you have got it or not.
Please repeat once again.
Now simply just look into this one, this A plus DPTR. That simply denotes the A plus DPTR, whatever the value of A and whatever the value of DPTR, that will be added up. Okay, so the value of DPTR is 1, 2, 3, 4H and A register is 5, 6H. So they will be added up and they will form the address. So now the content of DPTR is what? 1, 2, 3, 4H, and the content of A register is 5, 6H. So this will be added up. Okay, so after addition, this result will be 1 to 8H. Clear? So this 1 to 8H will be acting as the address, just like before. Okay, and at the rate of 1 to 8A, that means the content of the 1 to 8AH that will be moved into the A register. Clear or not?
Sir, clear.
So similarly, in case of the second one, that program counter, whatever the value of the program counter, that will be added up with the accumulator, and the content of that particular added up address, okay, that content of this address will be moved into the A register. Clear? Okay, so we are just going forward just a minute. Now the move data, I mean data movement operations has been discussed. Okay, so now we will discuss the data exchange operation. Okay, now the exchange data exchange operation, that means the exchange the bytes between register A and register RR. So in the first example, first mnemonic, that is XCHA comma RR. This is a very simple example. Simple instruction is, so the for example, that exchange A comma R3, that means the content of A and the content of R3 is exchanged. That means if whatever the data is in the A register and whatever the data is in the R3 register, that will be exchanged. That means the after the execution of this instruction, the content of A register will be moved into the R3 register, and the content of R3 register that will be moved to the A register. Clear? Similarly, in the second one, you can see this XCH A comma address. That means the content of A register that will be moved into the 80H memory location. Clear? And the 80H memory location content will be moved to the A register. Clear? So again, at the rate RP is there. XCH comma at the rate RP. That means exchange the bytes between register A and address in RP. Clear? So in the example, you can see the content of the R1 register that will be acting as an address. The content of that particular address will be moved into the A register, and the content of A register will be moved into that particular address that is located by R1 register. Clear or not?
Clear, sir.
Okay. So the last one is a bit different. xchd a comma @rp. Let me ask you, do you know this this term? Do you know this term? Can you hear me? Do you know, yes or no? Can you hear me? Am I audible to all of you?
Yes, sir.
So do you know that, please tell me that yes or no, whatever the answer is.
Yes, sir.
So Rajkumar, so can you tell me that what is the meaning of this nibble?
So value of content or the content.
Not exactly. I'm just sharing another one. Just look into this. You will understand that whatever I am talking about. Is it visible now? The PPT is
Yes,
Yes,
sir.
sir.
okay. So now just see that bit. That bit means 0 and 1. That is binary digit that forms the bit. Okay. So this 0 and 1, everything is constructed, or the binary digits are, you know that everything can be converted into its equivalent binary form, any decimal number. So these bits forms a byte. 8 bits forms a byte. So 8 bits means D0 to D7. Okay, you can see this bit is 8 bits. Okay, the number of bits is 8. Okay, so it forms 1 byte. So if we segregate these 8 bytes to 4 and 4, so lower 4 bits is called lower nibble and higher 4 bits are called higher nibble. Okay, so in connection, if 2 bytes are formed, then one word is there. Okay, so word consists of 16 bits. So in summary, we can see that the lower nibble, the nibble contains 4 bits that may be higher or lower, and 1 byte contains 8 bits, one word contains 16 bits. Clear? Now it is clear.
Yes, sir.
Okay, sorry. Yeah, so getting back to this, so this whenever this nibble exchange will be there, that is xchd a comma @rp, that means the 8-bit data is stored into the A register as well as the memory location pointed by RP register. So the 8-bit data, among this 8-bit data, the lower 4 bits of A register and lower 4 bits of that particular memory location that is located by RP register, that is exchanged, that will be exchanged. Okay, so this is the function of this instruction. And as you know that in this particular slide, the second instruction is holding only the 8-bit address. Otherwise, no instruction is having any 8-bit or 16-bit data or address. So except this second instruction xch a comma 80h, all the instructions are of single byte instruction. The byte length is single byte. Okay, only second one is 2 byte or double byte instruction. Clear? Now push and pop. This is very interesting one in case of stack pointers. So perhaps you have remembered those stack operations, whatever discussed earlier. I mean, in the earlier classes. So here, just remember that in case of stack operations, only two operations are there, push and pop. So in case of stack jump and call operations, during the jump and call operations, the stack is used extensively. Okay, and this push, that means we are adding some data on the stack top of the stack. Okay, so the process is first increment the address of the stack, then store the data onto the top of the stack. Okay, so stack is now this push instruction, that is incremental. That means whenever you are doing this push operation, then automatically the content, I mean the address of the stack is increased by 1 and the data is to be stored. Now which data is stored? The data stored, that means the content of that particular address, whatever written in this push address instruction, that particular content is to be moved into the top of the stack. Similarly, in case of pop means popping out of the data from the stack, top of the stack. So suppose that pop, I mean the stack top first delete and first pops out the data into the particular address. Just you can see this, if the instruction, we'll be discussing it just in the next slide also, that pop 01H, that means if the data is stored in ABH data is stored into the top of the stack. So after this instruction, what will be there? That ABH data is moved into or stored into the 01H memory location that is located in the internal RAM. Okay, and the stack is decremented by 1. Clear? So it will be clear actually. Just look into this instruction and the figures. Now we are discussing about the push operation. Please be careful. If you cannot understand, just interrupt me. Okay. Now first, in the initial stage, the stack pointer value is 07H. You know that after reset, only this stack pointer value is 07H. All other registers are reset to 00H except this stack pointer. So after reset, the value is 07H. Clear? So this is the initial stage. In the second stage, just look into this. Move R6 comma to hash 25 H, move R1 comma hash 12H, move R4 comma 0F3H. Now look into this instruction. No initialization has been done in case of the flag register. You remember the flag registers? So the flag register, this RS0 and RS1, those 2 bits are there. So these RS1 and RS0 actually selects the register banks. So no initialization has been done. So by default, bank 0 is selected. It was also discussed that by default, bank 0 is selected. So just remember that the address of this particular internal RAM area, I mean the register banks, the address of R6 is what? That is 06H. Clear? Now the address of R1 register in the bank 0, what is the address? What is the address?
01H.
Yes, very good. So we are writing 01H. Okay. And what is the address of this R4?
04H.
4H.
04H. Very good. Very good. So now look into these three instructions. Okay, so initialization has been done. Now first one is push 6. Just going back to the previous one, push address, that means we are giving some address into the instruction. So push 06H, the first one is push 06H. That means what? At first आंख बंद करके increment the content of the stack pointer. Okay, that means ये देखो, ये stack pointer एक increment हो गया. That means the content, I mean the present address of this stack pointer, sorry, the present address of the stack pointer is 08H. Okay, so increment हुआ, उसके बाद जो 606 hex memory location में जो data था, that is to be stored into the top of the stack. So the top of the stack is now 08H. ये देखो push 6, that means R6 register में क्या था? 25H. That 25H is stored into 08 memory location. Understood or not?
सर एक बार रिपीट कीजिए.
Okay. So this at the initial stage after the reset, the stack pointer value is 07H. Okay. Now after this push 6 instruction, this push 6, this one. Okay. So this after this instruction, the top of the stack is 08H. At first, just going back to the previous one, first increment the stack pointer, then copy the data into the address to the internal RAM address contained in stack pointer. So increment SP first. So SP is incremented by 1. Previously it was 07H. Now this is 08H. Clear? It is incremented. Now the content of that particular address, that will be moved to the new location, that is the stack top. So this content of 06H memory location, that is nothing but 25H. Clear? So 25 is stored into the 08 memory location. Now now the stack pointer is 08H. Okay, now when executing this push 1, this instruction, then the stack pointer is incremented by 1, that is 09H, and the address, that is the 01H. Inside this address, what is there? R1 register. R1 register contains 12H. So this 12H is moved into this, copied into this 09 memory location. In the next case, the present one is 09H memory location. The stack top is 09H. Okay. Now after this push 4, that what happens? After push 4, that stack pointer, stack top will be incremented by 1, that is 0AH, and it will take the 04H memory location content, that will be moved into the top of the stack, that is nothing but F3, this one. Clear? Now I'm just erasing all the everything. Now just see that you may ask, sir, why this is push 6, push 1, push 4 is written. It may create some ambiguity. Just you can write in your own paper that 06H and 6 in decimal, that is equal. Whether you have written 06H or 6 in decimal, then it is same as, I mean, this is equal. The meaning of this is same. Okay. So whenever we are writing this 6, 1, 4, so microcontroller understands this is the decimal numbers. If you are not putting any H, then the microcontroller will understand this is the decimal number. So you may ask, sir, इसको हम change नहीं कर सकते? So let me tell you, this is the manufacturer specification. We cannot do it. Manufacturers ये जो बना के देते हैं इसमें यही specification रहता है कि microcontroller will understand that if you are not writing any hex H in the program, then the microcontroller will understand that that the particular data is decimal number. Clear? Understood or not?
Sir,
Yes.
if वहाँ पे move R6 के जगह R7 यूज करते हैं,
हाँ,
then push पे क्या यूज करते हैं, 7 और 6?
ना ना, तुम ये तो 6 यूज कर दिए हो, ठीक है। अगर मान लो कि तुम R7 रजिस्टर यूज कर रहे हो, ठीक है, तो यू हैव टू राइट मूव R7। कितना डेटा स्टोर करोगे बोलो R7 में?
Sir has 35H.
क्या क्या?
35H.
FFH?
No sir, 35H.
अच्छा, ओके ओके ओके, जस्ट अ मिनट। Three 5H. Okay, fine, no problem. So you have to write after this push 4, you have to write here only that push. What is the address of R7 register in bank 0?
07H.
So you have to write 07H. Okay, or you can write push 7 only. This is same. This, if you write 07, that is same if you're not writing anything. So in case of this, the stack pointer again incremented by 1, that means 0B. So here, sorry, here the content of this 0B memory location, that will be 35H. Clear?
Yes sir.
Okay, so let us, I'm just calling your names. You just unmute yourself and respond. Okay. Proshanjit Patra is there?
Yes, sir.
Okay. Ayushi Priya? I cannot hear.
Yes, sir.
Yeah, okay. Aditya Singh?
Yes, sir.
Okay. Amisha Verma? Amisha Verma is not there. Ashad Raja?
Yes, sir.
Okay. Ashad Shukla?
Yes, sir.
Jairam Mardi? Jairam Mardi is not there. Jyotsna Nag?
Yes, sir.
Kumari Asthavala? Not there. Monorama Hasda?
Yes, sir.
Maria Umama? Maria Umama is there. MD Hetasham? Mustaq Ansari, MD Mustaq Ansari? Not there. MD Imran? Who is this? Mohit Ranjan? Not there. Monica Nagar?
Present, sir.
Okay. Neha Kumari? Not there. Pradeep Singh? Pooja Shah, Rahul Marandi, Rajkumar Rana,
Yes, sir.
Raj Laguri, Rani Rupam,
Present, sir.
Rashmi Kumari, Raunak Jaiswal, Rishabh Kumar,
Yes, sir.
Saubhagya Singh, Shalini Priya,
Yes, sir.
Shikha Maji,
Yes, sir.
Shreya Kumari, Shubham Sinha, Shushila Hasda,
Present, sir.
Tanisha Kumari, Vinod Kumar Rajak,
Present, sir.
Vishakha Kumari,
Yes, sir.
विवेक कश्यप ये तो नहीं है, लक्ष्मी कुमारी नहीं है. Okay, so this is the final attendance for today. Okay, thank you everyone. You can leave your class.
Thank you, sir.